to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom. So learn physics at your convenience. Let us start our today's lesson. The topic is multiplication of vectors. Students, you know that vectors do not obey the usual mathematical rules. They have their own rules for multiplication, division, addition, and subtraction. Today, we will discuss the product of vectors, means how the vectors are multiplied. Students, there are two types of multiplication of vectors. One we call scalar product or dot product, and second is called vector product or cross product. Now first we will discuss scalar or dot product. When we multiply two vectors and the product is a scalar quantity, we call it scalar product or dot product. This type of product is represented by putting a dot between two vectors, so we call it dot product. Students, consider two vectors A and B making angle theta with each other. Then their dot product will be A dot B equals to AB cos theta. Mathematically, A is the magnitude of the first vector, B is the magnitude of the second, theta is the angle between them. So the dot product will be obtained by multiplying magnitude of the first vector with magnitude of the second and taking cos of the angle between them. Again, look at this product. B cos theta is actually the component of B in the direction of A. Look at this diagram. B is a vector that is making angle theta, so B cos theta is the component of B that is parallel to A. So for dot product, first vector is multiplied with component of the second vector that is parallel to the first vector. For example, work is obtained by the product of force and displacement. Force is a vector, displacement is a vector, work is a scalar. So work is the dot product or scalar product of force and displacement. Similarly, power is another example of dot product. Power is a scalar quantity that is the product of two vectors, force and velocity. Students, you know that we take I, j and k unit vectors to represent the direction of x, y and z coordinates. So in case of unit vectors, you know unit vector is one whose magnitude is 1. So I dot I, the dot product of unit vector with itself, equals to magnitude of I, that is 1, magnitude of I and cos of the angle between them. Since angle between I and I is 0, so we will have 1 into 1 into 1, that is equal to 1. So dot product of a unit vector with itself gives 1. So I dot I or j dot j or k dot k, all of they will give 1. However, in case of perpendicular vectors, unit vectors, I dot j equals to magnitude of I, magnitude of j and cos of the angle between them. Angle between I and j is 90 degree and cos of 90 is 0. So the whole dot product becomes 0 when they are perpendicular to each other. I dot j, j dot k or k dot I equal to 0 due to cos of 90. Next is the multiplication of vector that we call cross product or vector product. When we multiply two vectors and product is also a vector quantity, then we call it vector product or cross product. Again, consider the example of two vectors A and B. Then their cross product is represented by putting a cross between them. So we call it cross product. If A and B are two vectors making angle theta, then their cross product equal to a third vector c, whose magnitude is equal to AB sine theta. A, magnitude of the first, B sine theta, the component of the second vector that is perpendicular to the first vector. Actually, this magnitude is the area of the parallelogram, whose one side is A and the other side is B sine theta. Look at this diagram. A multiplied by B sine theta base multiplied by this perpendicular side will give us the area of this parallelogram. So magnitude of C is AB sine theta, and since C is a vector, what will be its? Students, the direction of C is perpendicular to the plane made by A and B vectors. Look at this diagram. We join the tails of A and B, forming an AB plane. Now, vector that comes first in the product, that is A. A is rotated towards B through smaller angle, and right hand is placed on the plane such that fingers of the right hand curl in the direction of rotation of A. Then thumb of the right hand points in the direction of C. By this way, we can find the direction of C, and that is always perpendicular to the plane made by A and B. Again, look at this diagram. If first finger of the right hand is in the direction of one vector, middle finger is in the direction of the second vector, then thumb points in the direction of their cross product. A cross B will be C, and direction of C is given by the direction in which the thumb is pointing. Students, the example of vector product or cross product is angular momentum. That is the vector, that is a vector quantity, and it is the product of linear momentum and velocity. Second example is torque. Torque is a vector, and it is the product of moment arm and force. So these two are the examples of cross product. Students, now consider the case of unit vectors I, j, k. For unit vectors, I cross I equals to magnitude of I, magnitude of second I, and sine of the angle between them. Since I is parallel to I, angle is 0, sine of 0 is 0. So I cross I equal to 0. I cross j, k cross k will also be 0. Now I cross j. Consider this a circle in which I, j and k are directed anti-clockwise one after the other. Now we will follow this circle starting from I. I cross j equals to third, that is k. I cross j equals to k. Since k is a vector, its direction is important. Here, if we are moving clockwise, direction of it is positive k, plus k. And if we move anti-clockwise, means j cross I, then it will be minus k. Similarly, j cross k equals to third I, or in reverse order, k cross j equals to minus I. And finally, k cross I equals to j, or changing the order, I cross j, k equals to minus j. This is how we can find the direction of the cross product of two vectors. Student, this is all about the multiplication of vectors. I hope it is clear. Students, thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.